Coulomb's law with multiple charges. What do we do if we have to use Coulomb's law with more than two charges? For example, we have three charges here, Q1 positive here, Q2 negative there, Q3 positive there. Well, we make those connection lines and then we draw each force. For example, Q2 on 1 exerts a force in this direction. 1 and 2 also in that direction, but let's assume we only are interested in Q1 for the moment. So Q2 attracts Q1 in this direction. Q3 repels Q1 in this direction. I don't know how big I have to draw the arrows because there is no given on the magnitude of the charges, but it's just an example. F2 on 1 in this direction, F3 on 1 in this direction. We have two vectors. What we have to do is use the parallelogram rule, and we see the resulting force like this. Okay, best is to show this with an example. In this example, three charges are located on the same line. Charge 1 is located in the middle and has a magnitude of 20 microcoulombs. Charge 2 is at 30 centimeters on the right and has a value of 10.0 microcoulombs. Charge 3 is at 20 centimeters to the left of charge 1 and has a value of 15.0 microcoulombs. What is the resulting force on charge 1? Well, this is our given situation, our three charges, and these are all the data from the question. So Q1 20.0 microcoulombs, Q2 10.0 microcoulombs, and Q3 15.0 microcoulombs. Q2 at 30 centimeters to the right, Q3 at 20 centimeters to the left. Now we know that Q3 will exert force on we know that Q2 will exert force on Q1. They're both positive, so they repel. Of course, Q1 will also exert a force on Q2, but that is not given. We're only interested in the resulting force on charge 1, so we only draw this one. Q3 also exerts a force on Q1, F3 on 1. Of course, Q1 also exerts force on Q3, but not interested for the moment, so only those forces are drawn. We know that F3 is larger because the charge of Q3 is larger than the charge of Q2 and the distance is smaller. So we don't have to wait for the calculations. We already know F3 will be larger. And we know that both forces are in opposite directions, so we have to subtract them from one another, or at least put the arrows one behind the other. If we put F2 behind F3, we will notice that F resulting force will be like this. So we have to find the resulting force, and the solution is not this. I've seen students use this. Just put the three charges into one formula. Forget it. Danger. Away. No, we have to calculate separately. So we first have to calculate F2, because we have those two charges here. We only calculate this one. It's quite easy. It's just Coulomb's law. So we have our constant, 8.99 times 10 to the 9th. We have one charge, which is Q1, 20.0 times 10 to the 6th Coulomb, which is microcoulomb is 10 to the minus 6th. The other charge, 10.0 times 10 to the minus 6th. And then we have our distance, 30 times 10 to the minus 2 meters squared. Don't forget the squared. Gives us 20 Newton. We do the same for F3 on 1. Same formula, only now we have only Q1 and Q3. So 3 and 1 is our constant, Q1, Q3, and the distance, which gives us 67 newtons. Now we know they're in opposite directions, so we have to subtract them from one another. Fr is F3 on 1 minus F2 on 1, which gives us 47 newtons. Of course, if they're not on one line, you will have to use cosine rule. But let's find out with exercises.